So hi folks, how are you? I hope all of you are good. So this would be a long form video and this would be kind of a lecture. It's actually a lecture, okay, but not the usual one that you are very familiar with. We'll be having, will be learning this subject. We'll be having this intuition, right? We'll be having this deeper understanding about digital communication. I'll try to cover this all of the steps that is generally in a digital communication subject in an undergraduate or B.Tech level course in any university in India or in various other country, including United States and other Europe and other universities. So the thing is that we'll be having a deeper understanding, okay, of digital communication in a very less, we can say, in a you'll have to put up a very less amount of effort because we'll be hitting upon the intuition, we'll be hitting upon analogy, I'll try to explain you with different you know sort of way with so that you can learn it and keep it in your heart for a very long time. And we'll try to cover different nuts and bolts and all of the things that are involved with digital communication. So this course lectures are basically part of my book, my newly released book. So first let me introduce myself. I am Dr. Arya Dev Mehta. Currently I am assistant professor at Sarla Birla University, Ranchi. I have a PhD. I have earned my PhD from National Institute of Technology, Rourkela, that is NIT Rourkela, in Electronics and Communication Engineering. I have my M.Tech from DIT Pune, okay, that is Defense Institute of Advanced Technology, that is in Pune, a subsidiary or basically operated by Ministry of Defense. So I have done I have a lot of research exposures in defense as well as health sector for solving different health and defense related applications. So let's begin with the lecture and this discussion. Basically, don't take it as a lecture. It's basically a discussion which I am having with you all. Okay, so that we could be able to better understood all the different things that are basically involved with digital communications. Okay, so as I already briefed you, this will be a lecture series, not an individual standalone lecture. I'll try to cover it in 4 to 5 lectures. Okay, so basically we'll be covering a lot of things. Let me first uh, tell you what we are going to cover. Okay, so just be patient because this would be a long form video. Okay. Okay, so here is what we are going to cover in this lecture series. So this is a typical undergraduate or B.Tech fifth, sixth semester or basically higher semester courses. Some in some university, this is also this content is also taught in semester seventh and eighth. So we'll be covering the entirety of digital communication systems, digital communication as a whole. Starting, this is a general subject. You can get the idea of that is from that from. So you can also refer if you have a basic grip, if you have a basic understanding, okay, of any communication system, be it analog or digital, whatever, then I suggest you can go directly to Dr. Vikas, okay, from IIT Kharagpur, IIT Bombay, sorry, his lectures. That is also available. That is also is available in YouTube. Um, if you want to don't want to have a very wordy or very sort of uh, uh, loaded in simple word I can say a very loaded discussion in digital communication systems and all the concept regarding that, you can stick to my discussion. Or there is another way. Okay, I am trying to deliver you sufficient steps that is generally taught in universities. If you want to know beyond this, you can preferably go for Dr. Vikas lecture. Okay, that is available in YouTube, NPTEL, in different platforms. So let's begin. Okay, so we'll be try to it will be not possible, I think, to cover entire module in a single lecture. So I'll try to cover all of it in different lectures. Let's see how we can organize it for you so that it would be easier to you to understand. Okay, so the supplementary material that would be available with this lecture means this thing is my book. Okay, so this would be I have that would be this is made available at my own website. Okay, you can contact and you can purchase this book. So this is not very expensive. uh, and this is not like conventional textbook loaded with words and examples and a lot of different stuffs, like. So it's very quite straightforward. Okay, try to inject the intuition, try to inject the main concept. Okay, with the so that you have to put up very least effort. Okay, to understand and grab all those high level and highly detailed thing. So at the end, you can supplement these lectures with my book. You can come to my website, have this would not be very expensive. This would be very cheap. Like it's not I it's not it's everyone can easily get it. And you can supplement my lectures with this book, and you will be having a full package of for the entire semester. Also, if you are preparing for GATE, this will be helpful for you to get a very high level and also detailed idea of everything, how different things come together to form this system, and what are different elements that are involved in digital communication, and why they are so. So I'll try to teach you cover all. So kindly also you can comment and feedback in teaching method and all whatever feedback you want to provide. So comment section is always open for different kind of requests regarding framing and providing lectures, discussion, and all kind of stuff. So this is my outreach that is with all the students, not just in India but everywhere in this world. That's why at first I'm making all my lectures available in English. If you guys request, okay, because if with English I have a reach from down student from south and from different countries, everyone can be able to understand me. I can make a transcript in Hindi also, or if possible, if I get sufficient request, I will have a Hindi version will also be uploaded. तो हिंदी वर्जन भी आपका अपलोड हो जाएगा. So just you have to that depends upon what kind of response I am getting from you guys. So as I already told that the motive with the lecture series is to get you understand digital communication in very detailed manner. So let's begin. So we'll be covering in the first part, we'll be covering different elements that is associated with digital communication. So first of all, we'll be discussing advantages and disadvantages of digital communication. So prior to digital communication, you have already covered analog communications. So how basically digital communication, then why we suppose we have migrated to digital communication if analog communication was good enough. So what made us to right now you see all the devices that we are using are digital in nature, and even the communication method that we are choosing is also digital in nature. So why we have basically migrated from analog to digital. So we'll get to understand all those things. We'll discuss series and parallel transmission. We'll discuss communication channel characteristics. So what is basically channel and how it can be there different. We'll cover a very important thing, that is information entropy and channel capacity. Okay, so these are very important things that we'll be touching. Okay, and this information entropy, don't confuse with this with the entropy in chemistry or physics. You have heard in the physical world, in this closed system, entropy always increases. So information entropy is slightly different. However, it is somewhat analogous to the actual entropy in some sense, because that entropy is a random disorderedness basically. And this entropy in terms of information, we'll see this thing. This is a very detailed discussion and a very mind storming, you can say, mind teasing, brain teasing thing. uh, the thing is that data and information are different. Okay, so in the when we'll be covering this thing, we'll be discussing that. Then we will be discussing Huffman coding, a very important concept. So why in the source coding part. So what are source coding, what are entropy, all the thing, and we'll end up this chapter with receiver characteristics. Okay. So let's begin. So first of all, the very important thing is that what is digital communication after all, right? We know communication. Communication, in generally we say that I am communicating with you, right? You are not. You are also communicating with me, but that is one directional only, right? I am speaking, you are listening, and in some form, not with the your voice, but your comments and all. I am also getting your messages back, right? Means what I am thinking I am able to deliver to you, what information I have I am able to deliver to you, and you are also giving me feedback in some another mode. So in both both process, digital communication techniques are involved, right? The digital communication techniques are involved, right? So what are digital communication, will come to that. Okay. So communication in general is that thing only, the conveying information from person A or place A to place B, or place B to place A. Basically, when information moves, right, through space time, that is communication, right? So this is the general notion of communication. We'll touch upon very detailed uh, thing of that. Now, previous to digital communication, okay, their analog communication was dominant. Okay, which okay, the analog communication was very much dominant and prevailing. So all of you, the guys that is listening to you, most of you were not, have not lived in that era. Most of you guys are Gen Z and born after 2000 probably. Okay, some of you might have born before, like me, I have born before 2000. So back then we had analog communication systems very dominant, and it was everywhere. Means whatever communication system we had, that was dependent upon analog communication techniques, right? But right now, digital communication techniques are the dominating thing, and analog communication systems are almost gone. They have almost disappeared. The digital communication system definitely does have some advantages, such that this a piece of evolution, this piece of technological upgradation, made analog communication systems in a back foot, and they have almost been eradicated. There are at some places still we had analog communication, but most of them are digitalized, and hardly any communication system is there which is end to end, means from here to here, right? There is a point A or person A, point B or person B. So all the thing that is required from to move information from person A to person B is fully digital. There are very few examples of that. So first of all, we'll be understanding what is digital. So in digital electronics, which is the prior thing, you have already covered what is different between digital and analog, but it's still yeah, we have, since we have to have the very good understanding of digital communication, I'll try to cover that as well. So so analog, the basic difference between analog and digital is, so this is a typical analog signal. Okay, this is my analog signal. This is my time. This is also this is amplitude. Okay, and this is basically my analog signal. And digital signal doesn't look like that. Digital signal basically look like this instead. Okay, means digital signal basically can be represented with simply digits. That's why they are called digital, like 9, 2, 5, 4, 6, 7. This is also digits, right? Like, so let's say this is 5, this is 4, this is 6, this is also 6, like that. So anything that can be represented with digits, we say that is a digital, and anything that can be represented with continuous, basically continuous waveforms, that is analog, right? So in general, all the information, including whatever you name it, I will tell at the at original when at original level, at natural level, they were digital, they were analog, sorry. So everything naturally, most of most kind of signal, most kind of waveform, they all are analog, right? Just name a few, like I'm speaking, you guys are listening, and that is I'm just generating uh, a distortion in sound. This is my time. So this is like air molecules. Okay, and this is here is my mouth. Okay, pardon me for the drawing. I cannot draw my mouth properly, but this is my mouth. And there, just see, these are all the air molecules. So what happens basically, as I speak, no, this somewhere this air get thick, right? Because as my tongue and my vocal cord basically compress the adjacent air, okay, and this effect basically travels all along the space. So you have already seen these all things in your school, okay. So in when sound wave travels through air medium, so this is what happens. This is what it look like, right? So the our vocal cord basically pushes the air, right? Push the air that is adjacent to it, and that makes the air to bunch up to get dense at the very vicinity, and that the densification and rarefication. So obviously, if there would be somewhere, if there would be air will get dense, so do the air will get rare also, devoid of much air molecules. So mm, uh, this forms like a ripple and move all along the space, and that is how sound waves move. So in general, the sound wave is also uh, analog signal because it is continuous, right? So this is my time. I am drawing time domain representation of the signal. This is amplitude. In my y-axis, I am representing amplitude. In my x-axis, I am representing time. So as time progress, you see the intensity value or the amplitude value of my sound wave keep on changing, but that change is always continuous, right? Continuous means just think, just think. Let's just zoom in for a bit. Let's just zoom in for a while. Okay, just let's think for this point. Okay, so just tell me what possible value this point could take at this point means at this time. Okay, at t equals to t naught. Let's name this point as t naught. Okay, what is going to happen? What value this mm, mm, my sound wave can take? Let's name it a naught, right? So at t naught, I have a naught value. So just think, okay, just make use of your mind. This a naught can have any value, true or not. Any value in the sense, here we have 0. Let's give this 1, 2, 3. So I'm just giving different levels to this. This is -1, -2. Different levels to what? Basically the intensity, the amplitude, right? So amplitude can take any value, right or wrong. Any value in the sense that it is not necessary that it is almost always impossible that at a random t that you choose or I choose will be having exactly 1 or exactly 2 or exactly any proper any proper value. Okay, any proper value means basically any integer or any proper even rational number. So you all guys know what is integer and what is rational number. So first, uh, let me tell you. So then you will only appreciate. So our discussion so far is analog. Earlier, the communication was in analog domain. Right now, it is in digital domain. We convert signal to digital, and then also we do some digital communication. Make use of digital communication techniques. What are those? We'll come to that. First, you understand why analog signal is very challenging. So to make you understand, I am making all this plot and these stories. So now my point is in random, right? At any given time or any point you choose, like I have chosen T naught, which is having this value A naught, right? So it is very unlikely. Just tell how many numbers in this axis you go for this. Just in this axis, how many numbers are there between? How many possible values are there between 1 and 2, right? There are infinite values or not? Just think. Of course, it will having infinite real possible values, right? If you go for number line, we try to figure out how many real numbers that can fit between 1 and 2. It's infinite. So for not just 1 and 2, just even any two numbers, let's 1.1 and 1.2, even then we have infinite. So the problem with analog is that the value that it sweeps, right, it is generally infinite. Means it not infinite, it can take any values from set of these infinite values. You're getting? So from set of this infinite, an infinite value can be what? Like just give me a number between 1.1 and 1.2. 1.1 and 1. Let me tell. Okay, 1.11 is between 1.1 and 1.2. Another number 1.111111. That is also between 1.1 and 1.2. What else? 1.2457956. If you keep on writing this 78247925, keep on writing till infinite digits. Okay, means this would be definitely a irrational number. So this is also between these things. So similarly, uh, majority by and large, of course, between 1 and 2 there would be no integer. There would be no integer, right? Even there would be no rational number. So you know what is rational number? So rational number is basically something that you can, if suppose you can write a number as p by q, where q is not equals to 0, right? Where and p and q are integers basically, okay? Then we call such thing as a rational number. Means basically we are dividing p in some fraction. So this is a general form of rational number. So even rational numbers are very rare. Integers are already very rare. Between 1 and 2 there is no integer. Between p and q there would be of course infinite values of these rational numbers, okay? But this infinite would be, would be, this infinite would be smaller than the infinite that the set of numbers that basically consist of these irrational numbers, right? Because we here in p by q we can say, okay, let's write 9 by 10. So this is a rational number. We say that after 9 by 10, what would be next? 10 by 10. So this is also, this is basically integer also, rational number also. Now next is 11 by 10. So we can count this thing. What would be the next rational number here? But here we just can say how many rational numbers can be there, because you say this is you just count, okay? You just keep on writing, throwing random numbers till infinite. What will be the next irrational number to that? Just think. So there is no meaning of next, no? We are writing this number till infinite. So basically, my point is that in analog signal, most of the value that the the signal can take will be likely a irrational number. And irrational number basically would require infinite amount of digits, infinite number of digits, right? Infinite number of levels of precisions, okay, to be written, right? So this is the first challenge that basically limit this analog signal, right? That's why we cannot process, or we cannot just write analog signal as numbers, because then we will not be able to use them. So whenever we are hitting infinite somewhere, okay, then that is a red flag, okay? Means definitely it's not the right choice and not the right way. So analog signal basically can take infinite values. Any point in analog signal can take infinite values. And also in the time domain also, next since this is continuous, and continuous means, no, we cannot say suppose what is the next instant of t naught. We cannot tell, basically depend upon how small we are considering. So next instant of t equals to t naught would be definitely plus some del t, right? But how small this del t uh, would be of course very small, right? So again, there would be infinite time domain values, and there would be infinite, amplitudes that each of the values can take. So this is what makes an analog signal very difficult nut to crack, right? That's why our analog signals can't be done, that can't be used, processed with a we studied digital computer and all. Okay. So analog signals are very clumsy and they requires a lot of digits, lot of infinite, and it is definitely practically impossible to do a lot of things with those analog signals, right? So in earlier days, we do not have any